Is this microphone? Okay, this will work. All right, so our first speaker is Jeffry Lang. He is the Director of Cyber Defense Operations at Virginia Tech. Jeff Lang has been with the Virginia Tech Security Office since August of 2012 and brings with him 16 years of IT experience before joining the team. Jeff was computing technology manager for the Virginia Tech School of Architecture. He has experience with network monitoring and forensics, intrusion detection, and configuring security appliances. Jeff has a BA in philosophy from UNC Greensboro and a master's of information technology from Virginia Tech. He is a SANS certified intrusion analysis, Windows security administrator, network forensic analysis, Python coder, cyber threat intelligence analyst, and certified enterprise defender. So
Yes.
Jeff is going to be doing a talk today on ransomware.
Where's it coming out of? Okay. I just had to.
And I'm going to let him take over now. Thank you, guys.
Good morning. Thank you for having me today. I appreciate the opportunity to talk a little bit. We're going to talk today a little bit about an incident that happened at Virginia Tech last year. We had some departments get hit by the Kaseya ransomware, and we've been actually very open about what happened, the steps we walked through, and the things that we kind of learned from it. And so hopefully this will share some information with you and be a good talk. So, thank you. So again, I'm Jeff Lang. I had the introduction there. The responsibilities that we have with our defensive operations are our security operations, network monitoring, incident response. We've got computer forensics, and we deploy all of our security tools, maintain them for our monitoring operations. My email's there. If you have any questions, feel free to shoot me an email. I'm always happy to talk and share the information that we've got. So just as kind of a background about Virginia Tech, our main campus is in Blacksburg, Virginia, which is in Southwest Virginia in the beautiful mountains. We do have a large presence in Northern Virginia, though, and we're actually building an innovation campus there. It's under construction now, and that's in Alexandria, Virginia. When I took the last statistics, we had about 37,000 students. Enrollment is actually up, so that's probably closer to 42,000. And we're ranked number 48 in research institutions in the United States. 9 colleges in our graduate school, 110, 170 programs. We're a fairly large Research One university. But our IT infrastructure is very distributed. We have a few services that we provide centrally, things like networking, email, our courseware, various infrastructure mostly is all provided centrally. Our security office provides services centrally as well, but most of the hands-on IT stuff is done at the distributed level. Every department has their own set of IT staff. Some of them are very competent, very large staff. Some departments are much smaller and have a smaller set. So we have a lot of challenges that we go through working with different levels of people, different technical expertise, and different availability with them. And so those provide a lot of interesting challenges, especially, and this, as you go through and you talk about best practices for security, and you get a lot of gasps when people say things like, never have RDP open to the internet, never have SSH open. Well, many of the Research One institutions are open. We have no network firewalls except in limited places. Security is at the host level, and that provides a lot of challenges as well. We don't have that centralized management of things to try and control and do a lot of the security layer on kind of that outside edge. Our security office, we have 10 people total, 4 people on our defense team, including myself. We've got our architecture red team, our risk management team. We're working on getting a 24/7 security operations center up. So we have an associate director who's kind of working with that. And then we also have added a software developer to try and help with the projects that we have going on. So that's 10 people total across the board doing all the security operations for the university itself. So what ended up happening last year, Friday about lunchtime, right before the 4th of July holiday weekend, everybody was ready to have Monday off and ready to go. And people started coming back from lunch and opened their computers and had these weird files on their desktop. They clicked on them and they were encrypted, and there were text files saying, hey, you've been hit by ransomware. You need to go to this site to check out how much it's going to cost to get your data back. We started getting some phone calls in at the security office from one of our departments, and they were like, hey, we manage this thing called Kaseya VSA. It's a security administration software package. It allows you to push patches, install software, remote manage, and they were like, we've got all these people who are connected to this device, and they're all getting hit by this ransomware. So it turned out there were some flaws in that application from Kaseya, and there were a number of people hit by this. So we started scrambling to try and figure out what was going on and what was happening. And it turns out that there was a group that used Sodinokibi and attacked all the machines we had on our network that were connected to the VSA server. It turns out it wasn't just us. It wasn't a targeted attack at us. It was targeted at Kaseya, the VSA appliance. So this was a supply chain attack. They didn't attack us directly, but they attacked a vendor that we worked with. And the primary targets were actually managed service providers. So there were 60 MSPs that were impacted. There were a handful of other areas like Virginia Tech that got hit that weren't really an MSP. But it was over 1,500 clients of those MSPs. It was a huge attack surface. And it only attacked their on-premise software. So their software as a solution in the cloud wasn't impacted, but they did shut that down as well, because just in case it was something, they didn't want that to happen. So kind of the details of what it was. It turns out there were 7 flaws that were exploited in order to get this attack to happen. The CVEs are all listed here. SQL injections, cross-site scripting, all sorts of pretty normal and things you'd expect not to have in a management application like this. What they did is they uploaded an initial payload through a bypass, and once they had that, they used the SQL injection to execute that file. And once they had that, they had administrative access on the entire VSA appliance. So once they had that footing, they were able to push out software to every client that was managed by those VSA servers. They downloaded an agent.crt file, and they pushed it into the Kaseya directories that were protected and were trusted. So, this is admin access. This can install software, and the operating system allows it because, this is a trusted component. So they actually were able to run a PowerShell script that disabled Windows Defender and then downloaded some additional files. They had the cert.exe, which is a standard Windows executable. They used it to decrypt an agent.exe file. So now they had their own agent running on all the boxes that the VSA managed. Wrong way. So once they had that, they actually used it to download vulnerable software. And this was an old Microsoft anti-malware that had a sideload vulnerability. So they downloaded it, It's msmpeng.exe. That actually looks like a valid file, and for a long time it was a valid Windows file. So if somebody happened to see that running, you're not going to have any question about that. You're like, oh yeah, that's the anti-malware, and that's fine. They were able to sideload a DLL file, and then that DLL file told the anti-malware to encrypt files, and to do it in such a way that you couldn't do things like shadow recovery or rollback. So basically in place, you couldn't recover those. At Virginia Tech, it turned out we had 3 of these servers running. Only one of them was compromised. It was the one that had its administrative access open to the world. So port 443, pretty common, pretty normal, but you question maybe why was it there, and we have some questions about that as well. Now the deed was done and we needed to recover from it. The department that managed it, they also allowed 6 other departments to use it. They had already invested in the infrastructure and were paying for it, and they said, hey, why don't you guys use this too? So all of those departments were impacted. 111 servers and 805 endpoints in those 7 departments were encrypted. All the files on the machine, all the documents were encrypted. Also, it followed any map drives, any synchronization drives like Google Drive or Microsoft OneDrive. And we actually had multiple file servers that were encrypted. So we had terabytes of data on file servers that were encrypted and from the endpoints themselves. So what did we do? Well, first we shut down all of those VSA servers, even the ones that did not get compromised. At the initial response, we didn't know what that vector was, and so we were like, let's shut them all down. We also shut down the network portals that were connected to them, just in case a VM popped up accidentally. We knew that no network traffic could get to it. At Virginia Tech, we have kind of our computer incident response team, a cross-functional group of people. We have some guiding documents. I have a link for that later in here. We activated that team, and so we were able to bring a number of people together and start having conversations kind of across the university with the departments and with additional resources that we could bring to try and discuss what our next steps were. We notified all of our senior IT management, which is part of that CERT, is to get out notifications so that the university knows what's going on. We contacted the Virginia Tech Police. They are a full police department, so they opened our initial police report, which we then were able to report to the FBI, and that was in Richmond, Virginia. That's our local hub, but they didn't have a lot of information because it was being actually run out of the Austin office. So they forwarded some information to us as their regional office received it from Texas, and we kind of went from there. We also opened a case with the IC3, submitted that so that we had kind of our paperwork done and everything going on there. We did open a ticket with Kaseya, which was very important. Since this was now a widespread event across their product, they kind of took the lead on incident response. We provided data to them that we had, and other organizations provided data as well for them to test and to figure out everything that was going on. We started having daily Zoom calls. We had actually 2 on that Friday, and then one Saturday and one Sunday. I remember standing at the grill and then going into the house and sitting down in front of Zoom and talking to senior management and the departments to get status updates from that, and then to go back out and try and help finish off the 4th of July party that we had going on. So once we kind of got our grip on what was going on, the department started to identify all those machines that were out there that they needed to basically go to and figure out what needed to be done next with them. We decided that basically we're going to restore from backup and then wipe every machine and replace it. So they began that process of identifying things and giving us status with that. And once they did get that restored, they started scanning for PII. So any confidential data, any student records, anything like that, we needed to know if anything was on those machines. And then we also had to get in touch with the Department of Education or report to them. So we had weekly meetings with them, update them on our status throughout everything that was going on. So the request for the ransom actually came through the REvil group. They are a pretty widespread ransomware as a service organization. They announced on their happy blog that, yes, we did this. Haha, look at us, we're great. We received permission to negotiate, and we got a number from them that was $44,000 per decryption key. There was some confusion with them trying to figure out exactly what that meant. And ultimately, it meant that every one of those machines had its own unique decryption key, and it was going to be $44,000 to pay that. We did some negotiation for about 30 keys. We had some thoughts that we might need to potentially pay some ransom, and so they dropped that down to $700,000 for those 30 machines. A few days later, and you can see the announcement, they decided that they would rather just offer out a universal decryption key for $70 million, and of course, nobody took them up on that offer. So as we were going through kind of the review, one of the departments realized that they didn't have good backups that they held, and so they needed to think about paying the ransom for it. And that's how we got to that number of 30. They said this would probably do us, and we kind of added in some for some other departments in case we needed kind of that overhead. So we reached out to our cyber risk insurance, which at that point we realized we should have done that at the very beginning. It's one of our lessons learned that we'll talk about in just a little bit. But they would have been able to negotiate on our behalf. They have people who that's kind of their job. So we potentially could have gotten, a much better deal on that. But fortunately, we found out that we didn't actually have any systems that needed to be recovered from the ransomware using a decryptor. So the department that was running it, they had their VSA server running on a Hyper-V VM on a Windows server that was itself managed by the VSA. So when the encryption started happening, it started happening on those Windows hosts that were hosting those VMs, and it basically ate themselves. So it shut down all the VMs, shut down the servers, and when they were able to actually get at those VMs, they realized that they hadn't encrypted. The data was still on them, and it hadn't even downloaded the agents to those VMs. So they were able to go through a process and pull that data and not have to do the ransom. So fortunately, we decided we were done with that. We stopped all communication with them and kind of went from there. We did have a tabletop earlier this year, and we had a lot of senior management with the university, and our university president, Dr. Sands, said, hey, any ransomware I have to approve. No one else at this university can pay it. So it was something good to kind of get that perspective and say, oh yeah, any decisions we might have, you have to take it to the top. You can't have someone, even the CIO of the university, make that decision. It had to go all the way to the top. As far as decryption keys go, REvil and their infrastructure disappeared on July 13th. They fell off the face of the earth. No one really knows what happened. Well, someone probably knows what happened, but we don't know what happened. On the 22nd of July, So this was 20 days later. Kaseya announced that they had a universal decryption key. So that was great. We signed an NDA. We actually had our library had a digital archive of scanned images. We have a big architecture program, so it was a lot of architectural drawings that they had accumulated over the years. It was a few terabytes worth of data. They had basically decided not to recover that data. They were just going to recreate it as people needed it. And they were actually able to use the universal decryptor and get access back to those devices. In September, we all found out that the FBI had that universal decryptor key for about a week and a half before they provided it to Kaseya. So there was a lot of response time and a lot of effort that was going on that perhaps could have been avoided if we'd had that decryptor a little sooner. On September 7th, the Our Evil group came back, and in May of this year, they started updating the ransomware software, and it's under current development now. So they kind of went away for a little bit and then came back just as annoying as before. So things, some things went really well as far as the response. Of course, not having it would have been a better thing, but it happened. And so our CERT activation, those things went overall very well. They allowed us to bring people together and to have communication across the departments. One of the biggest things from the first call we had with senior management, it was never a blame game. It was never fingers. It was, okay, this has happened. How do we recover? How do we work together to make sure that we get our data back and we ensure the integrity of the data that we have? That made a huge difference because nobody then was blaming someone else. So we were really sharing everything. There was no impetus to hide things that we found or, be disingenuous about something. And so that made a huge benefit to us overall. The departmental response was very quick and effective. Within a few weeks, they had gotten most of the systems recovered that they could, and they were moving forward to get things taken care of as they could. We did run into some issues, but that'll generally happen. We maintained our daily updates for the first 2 weeks, and then we had a weekly call, and then we had, once a month calls, and then finally we did get it finished out. So that was good. Everybody attended. Everyone was there from all sorts of different. We had university legal represented, our risk management group. We had all sorts of people involved. We also, during the initial event, we had a lot of response from our central IT. Although it was in a department that this was going on, they supported all the work that needed to be done, cutting those network portals. We had some centralized backups that they immediately changed the data retention period so that we could roll back and we wouldn't overwrite files on the central storage. They even provided physical hardware. So the initial group that managed the VSA server, they had, they needed a large box that was able to host those VMs so that they could see what kind of damage was done. So our enterprise systems had a box that would do that. And so they lent it to them so that they could stage the way that they got things going. And then we also have some staff that supports the division of IT internally for desktop support. They also handle things for our VIP clients. Their services were offered and they helped reformat, reinstall, and reimage machines to try and get people back up and running. We also had pretty good network forensics. We immediately started looking to try and find out, so hey, is this an encryption-only event or is there also data exfiltration? The responses are very different based on which one that is. We determined that we did not believe that there was any data exfiltration going on, and Kaseya later confirmed that this was an encrypt-only attack and it was not a data exfiltration. So that worked pretty well, but not everything was good. And again, that first thing, why was that administrative interface exposed to the internet. There were some needs for some of the VSA to be exposed to the internet, but perhaps they had a little too much. So, that was kind of a key piece that's kind of got the ball rolling. The other thing, our business contacts in our CERT document had gotten stale. How many of you have ever put together a big document, list a whole bunch of people's names only to find out later that they've all left the company and now you don't know who to contact? Well, that happened with us. It caused us to miss out on some important communication, kind of the risk management and some of the other areas. The university risk management, also, we didn't have any contact with the university emergency management. They usually deal only with, like physical emergencies, a fire on campus, an event that happens. They have a lot of resources though, and they also, we're bridging between, things that happen physically and in the virtual world that are all linked together. And so they didn't get contacted, which caused some delays in them reporting the incident to the Commonwealth Emergency Management Group. We also, and kind of one of the big keys is we didn't know where our high-risk data was at. We didn't know what had PII or student data. The departments hadn't really kept tabs on a lot of stuff. We had terabytes of file storage that had spreadsheets that went back 20 years. And so we had to treat every device, every machine, almost 1,000 machines, as having high risk data on them. So everything had to be scanned, everything had to be done, and that took months to do. Imagine trying to scan with a regex across 3.5 terabytes of data. It's painful, to say the least. So that was a huge issue, that we just didn't know what data we had and where it was. We also had this little thing called move-in day come August, and that 37,000 students showed up all at once, and all the faculty and staff to support them all needed updates. So for that start of the semester, things got pushed as far as some of those scans went, and it really delayed us getting the resolution finished. The Department of Education had recently made some changes about reporting deadlines. We actually had 72 hours to report the incident from the moment we had any thought that something was going on. We barely made it in on Sunday morning with that information to them because that group was one of them that had changed the leadership, and we didn't have the contact information. And so when we finally got it, we were already about 48 hours into that period. So there are a lot of things that just kind of just didn't happen the right way. We asked them, what machines are impacted by this? And they were like, I have no idea. We were like, well, why not? It's like, well, VSA managed it. So the inventory of all the machines that were supported by VSA was VSA, and now it was gone. So they didn't have any reports. They had nothing that they could go back to and say, hey, these are our devices. This is what we have, and this is what we need to do. So now, again, they had to go to every computer that they owned in their departments and say, was this a VSA managed machine or not? Did it get encrypted or did it not? So that delayed things a lot. I already kind of mentioned the size of some of the files. Even though the library got the universal decryption key, they didn't have 3.5 more terabytes of storage to do a decryption. Because in fact, you need another 3.5 terabytes of storage because you don't ever want to run that weird decryption key across your original file. Because if it messes that file up, that was your one chance at it. So you want to make a copy of that file. You want to decrypt that, and if everything goes right, that's great. Now you have the decrypted file. So they actually had to do it in small batches, and that just took time for them to run through that and get that process done. Our physical forensics, we were able to support doing 1 or 2 forensics images at a time, and now we had almost 1,000 machines that we're looking at doing forensics for. So we weren't able to do that. We basically just said, bring us an example of every type of machine that was compromised and encrypted. So we had a copy of a server, a copy of a desktop, and like a copy of a laptop. And that was the best we could do. Fortunately, we didn't need those forensics images, but it would have been great to have them. So what recommendations kind of came out of this? We had, a lot of things worked well, but a lot of things that kind of were gotchas for us. So immediately it's, the minimum thing is if you've got an admin server of that, that kind of admin privileges across your organization, make sure that you really do have it protected and you don't leave it open. For us, it should have been restricted at least to on campus, and anybody who needed to access it remotely, that would have, used the VPN, come through with that. We also recommended now that we need to take all those sorts of systems and do security reviews for them, make sure that they're doing the best practices and that they're protecting, logging, and monitoring additionally with those services so that we know that they're as protected as we can make them. Our business continuity, I mean, we made it through, but our business continuities in different departments, they couldn't cover from some of that because they didn't have servers. They had to borrow servers from the central IT. They have the storage to decrypt things. So all of that should be in your business continuity. How do you get yourself back up and running? And that wasn't there. So that was an issue that we'll have to deal with moving forward as each department goes through and kind of builds those. That incurs extra cost and extra thought in what you do with that. So one of those cross-functional groups was our purchasing office. And they were there and they were looking at it and they were like, so, they pulled the paperwork and we did a security review of Kaseya and the VSA when it was first purchased, but they'd had that thing for 7-8 years now, had done upgrades along the way, and there had never been another security review done on it. And so that made us start thinking that, maybe at renewal time, you need to at least get a certification back from the organizations that they're doing the things that they said they were. They said they did it at the beginning, but who knows what's changed and what's happened at that organization. We were also going through a major incident, IT-wide major incident process review at the time. They were formalizing it in ServiceNow, which is our trouble ticket system. And it basically deals with how you communicate to your stakeholders, the university at large, when you have something like email going down or Canvas, the course management that's having issues. And we needed to integrate the security side into that because that would have automated all of those initial communications that we needed. We wouldn't have missed people because we would have already formalized it, had it, and had review within there. And we now have done that, and hopefully anything moving forward needs to or would go through that process. We also want to start conducting some tabletop exercises. Fortunately, everybody came together and worked really well. But what we need to do is make sure that when we bring all those people in, they know their roles, they know their responsibilities, and what needs to happen and take place. And so we can focus these tabletops around things that we know are likely and some things that are unlikely that could happen, and just to make sure that everybody knows what they're doing and what's going on with them. So we finally got everything kind of taken care of. All the machines that were encrypted were wiped completely and reinstalled. There were no rootkits. There was nothing that caused us to have to throw away any hardware or hard drives. So we were able to wipe and rebuild all of them. We rolled back all the data on the shared drives to a clean state, and then at where they could, they did those decryptions. We did have some interesting adventures trying to roll back Google Drive and Microsoft OneDrive. We had to have an engagement with Microsoft in order to do that, because otherwise we would have had to have done it one OneDrive account at a time. So Microsoft partnered with us, helped us out with that, but it still took a long time to do. Like I said, we had to treat everything as high risk. So we were scanning all of those shared drives, those terabytes of data for PII and for student records. That took until December. And that was just, it dragged out and dragged out and dragged out. And finally, in January of 2022, we provided the last data that was needed by the Department of Education, and we basically closed out the incident at that point. At the end of it, there were over 129,000 student records that needed to be flagged in our system. And that basically was saying that there was an event that happened with their account, but there was no data exfiltrated out of it. That's a requirement by the Department of Education. And most of those were students who hadn't been with the university for 10, 15 years. Because it was all old Excel spreadsheets, now everything like that is tracked, in systems, and data is encrypted in databases. But back in the day, all we used was Excel. So we had digital cruft that just lasted and lasted and caused us to have a lot of these headaches and a lot of these issues going forward. And now, so, say, oh yeah, the event's done, but it isn't really done. Our Board of Visitors, yes, our BOV was very concerned, of course, at the end of this incident, and decided to engage Deloitte to come and do a across-the-board, university-wide review of security practices, and in different areas, not just the security office, but within the departments, and how they treat data and what they do and how they go through it. They spent a couple months going through that, putting together a lot of recommendations for us, and then kind of came up with, I forget, at least 6 IT-related recommendations. There were some management-related recommendations, but with the idea to try and strengthen security and make sure that we have all the communication that we need together. It actually got us 3 positions at the security office that we're now hiring for, and then 1 position to work with endpoint management that was one of the recommendations to improve what our endpoint management solution was. At the time, it was left up to the departments to roll whatever they thought was appropriate. Now we're kind of moving into something that's more centralized and can be managed in the division level, at the division of IT, and used by everyone. We're also in the middle of an internal audit. Of course, the auditors are taking a look at, not just the processes that we have, but they're looking at all these results and all these recommendations and things from the Kaseya incident and saying, did you do what you were supposed to do? How did you compare to what you say you're going to do? And that's a good thing because it ensures that we're following the procedures. It ensures that we're looking at them, of course, and making sure that they're appropriate for what's going on. One of the big things that kind of came was that, we had that stale data. We had a document that was supposed to be a living document that just sat and collected dust for 4 years without anybody looking at it. So things like that are what we're focusing on, trying to get that moving forward, putting in some new security standards on the high-risk data, identifying and inventorying what that high-risk data and those high-risk machines are within each department and each area. And it's going to take some time to get there, but we definitely have a lot of steps a lot of this were things that we wanted to do, things that had been kind of hit on in internal audits and external audits that we'd had before, but it always comes down to money, right? How do you afford to do these things? And because of the severity of this incident, the board said, hey, okay, we're tired of money as an excuse. We are going to fund these projects, and we want results, and we want them now. And so we're in this process of transformation. There is a link up here. It's open to the public. Any information that's there, you can read and see kind of the things that we have going on. And that's really what I have for you today. I don't know if anybody has questions, whether we have some time now to do that or afterwards in the hallway. I'm more than talk, and we can go from there. Okay. I saw this hand first.
Two questions. The first is this preventable from the Virginia perspective?
So the question is, was this preventable from the Virginia Tech perspective? Had that VSA server not had its web admin console open to the world, it would not have been compromised. The group in question, they have machines around the world. They're an outreach group that does a lot in other countries all over. And basically, the VSA was open so that they could communicate with all of those machines, no matter where it is, that weren't on our campus, that weren't in our network, basically. Unfortunately, the web admin interface didn't need to be open to the world. So had that been done, they could have left the ports open that just needed for that communication. And in that case, it would not have happened because they wouldn't have been able to access it.
The second question is, you mentioned like the architecture has their own department, I would imagine other departments have their own IT people. Were they consulted and brought in to know security planning? Or was that kind of like a university IT is running the show and they get brought in and rerun what's actually going to happen at the 30th?
So the question is, with our distributed IT, are they part of the decision-making process on how things go, or are they basically given the information afterwards? The answer to that is really both. There are certain decisions that are made from an infrastructure level, as far as like networking, those things that are kind of brought down and said, this is what we're doing. We do have meetings twice a year with the departmental groups. We're getting ready to have one next week where we talk about what's coming and what's going on. But as part of this transformation, every one of those projects that we're doing has representation from our departmental IT and the different areas so that they can provide feedback and input into the process. I believe one question in the back there.
Forensics and recovery, that just dragged it on. So going forward, is there anything that across the board, across all these different departments?
So the question is, are there data retention and maybe data labeling things that we can do moving forward to try and mitigate having the information that lasted so long there? Is that?
Yes.
Okay. So we do have a data retention policy. There are records management policies provided through the Commonwealth of Virginia and Virginia Tech policy, and they just weren't followed in many cases. So that's one of the kind of education things that has to happen, is to make sure that we have departments doing what they need. As far as data classification, one of our point protection transformation projects is also to do DLP and labeling. And so we're moving forward with trying to get that in place so that we do have protections on that data. So even if it does stay for longer than it should, and that data got, exposed somehow, that they wouldn't be able to actually access and read it. So yeah, those are projects that are underway and going. Thank you, everyone. We can talk after.
Oh. We do have a little gift for you. Something inside the book there.
Thank you very much. It was my pleasure to speak. Enjoy the rest of the conference.